Good evening, everyone. So today we are going to see an important characterization of GP. We will find a relation between GP and AP. Okay. So if till now, if you have not subscribed my YouTube channel, subscribe it for such type of interesting questions. Okay. So let's start today's session now. So suppose, you can say this is a question. Okay. This is very important question. Let AN, A2, A3, okay, A4 be a sequence, okay, such that each AN is greater than 0 or N belongs to N, okay. Then A1, A2, A3, AN minus 1, AN, AN plus 1, and so on is in GP if and only if log A2 upon A1, okay, A2 upon A1, sorry, if and only log A1, log A1, log A2, log A3, log AN minus 1, log AN, log AN plus 1, and so on is in AP. Okay. This is in GP. If we are taking log, this becomes in AP. Okay. So we'll prove it. Okay. Let's do this question. Okay. First, suppose that A1, A3 up to AN minus 1, AN plus 1 is in GP. Okay. If it is in GP, it will look like A. This will be A term because GP will look like in this form. AR square, AR to the power N minus 2, AR to the power N minus 1, AR to the power N, and so on. Okay. Because GP series or GP progression look like this. Okay. Where R is a common ratio and A is first term. So what is now? Now we are to show that. So we are taking log A1, log A2, log A3, log AN minus 1, log AN, log AN plus 1. Okay, we are to show that this is in AP. So what is, we have to check common difference. If this common difference is same, then it will be in AP. What is log A1 minus log A2? What is this? Log A1. Log A2 upon A1. What is this? A2 upon A1. That is log AR upon A. A and A will be cancelled out. It is log R. Okay. Log A3 minus log A2. That is log A3 upon A2. That is log AR square upon AR. After solving it, you will get R. That is log R. Okay. Similarly, going in this way, what we will get? Log a n minus log a n minus 1 will be also log r. Okay. Okay. And log a n plus 1 minus log a n will also in log r. Okay. So in this way, common difference is coming log r. Okay. So this implies log a2 minus log a1 is equal to log a3 plus log a2 log an minus log an minus 1 is equal to, that is, and so on. It is coming log r. That is my d. That is my d. These differences are coming common. That is d. It means log a1, log a2, log a3, log an minus 1, log an, log an plus 1. This is in AP. This is in AP. So one direction done. Conversely, suppose that log a1, log a2, log a3, log an minus 1, log an, log an plus 1 is in AP. We will show that a1, a2, a3 are in GP. Okay. So this is AP means what? This is it means log a2 minus log a1, log a3. This implies log 3 minus a2 is equal to log an minus log an minus 1. That is, and so on. That is common d, because they are equal. That is common difference. Okay. So if we take these two terms, what we'll get? Log a2 minus log a1 is equal to d. So we can solve it. It is log a2 upon a1. So we are calling it, yeah. So it is, so what is this? Log a2 upon a1, that is d. After solving it, we'll get a2 upon a1, that is e to the power d. Now log a3, you take this with this. Log a3 minus log a2, that is d. After solving it, get a3 upon a2, that is okay. So you will get a3 upon a2 is equal to e to the power d. Okay. So after solving it, you will get a2 is equal to a1 e to the power d, a3 is equal to a1 a2 e to the power d. Okay. And so on, continuing in this way. Continuing in this way, what you will get, because this is log a3 upon a2. What you will get? Last an upon an minus 1 is equal to e to the power d. This implies an is equal to an minus 1 e to the power d. Okay. So put r is equal to e to the power d. Okay. And a1 is equal to a you take. So what is, I can write it a r to the power 0. What is a2? A2 is a1 e to the power d. I can write it a r, that is a r square. Sorry, a r. I can write it. Okay. What is a3? A3 is a2 e to the power d. A2 is AR and e to the power D is R. Okay. Similarly, continuing in this way, what will we get? AN will be AR to the power N minus 1. Okay, and so on. So what you got? You got A1, A2, A3, AN. This term is A and this term is AR. This term is AR square and this term is AR to the power N minus 1 and so on. This is in GP clearly. So prove. So question is done. Yes, done. Okay. We have proved. Okay. Thank you very much for today's session. If you have any problem and issue related to this topic or question, you can comment in my YouTube channel. Thank you very much for today's session. Thank you very much. Like, share, comment and subscribe my YouTube channel. Thank you very much. Thank you very much for today's session.